think my audio is working. So in this session, I'm going to go through, or at least attempt, challenge number 7. It's force. So yeah, first I'm doing some housekeeping work by committing our last problem together. We did delegation, so I just have to submit that up to GitHub, and then create another branch for this problem. Okay, let's actually come to terminal. Just have to send some messages real quick. Actually, let me mute Discord just in case. Alright, let's get back to it. This should be cleared out. Okay. Alright, let's just set up everything for this problem before we jump into it. Let's change this back to template. Let's also change this back to template. And we have a few things. So we want to bring in this contract that they use before we even know what the challenge is. So let's just go ahead and get it set up. So we have force. I got force.sol, and my attack contract is already set up. And then let's also hit a oh yeah, let's go ahead and clean this up. Oh damn. Honestly, I need to do what Matthias suggested and start using type chain. Honestly, I need to practice with that more, especially before I start with Foundry stuff. But I really don't know when I'm gonna make that switch. It's kind of weird when you get into the flow of like challenges and having your environment set up into um, cool. I think I just saw my friend's gonna be joining. Um, to get once you get your environment set up in your flow, it's kind of difficult changing things up. Um, so basically, I think I'm gonna keep continuing with regular JS, and then probably sometime in the future, if I'm practicing on my own, or if I host study sessions where I practice with it, I might share it. But I think for now, I'm just gonna continue with this flow, and then I'll probably jump over to type chain whenever it gets to the point where I will really need it, and this just gets annoying. But ultimately, we'll start practicing with that later. So um, let us check out this contract. And I got cold. All right, let us check out this contract. So force looks like it's just a cat as comment. There's no actual functions or anything. So okay, so let's go ahead and make sure our progma is good. 8.0. And there's really nothing here. So I think I already remember what this one is supposed to be about. But let's go take a look at the requirements. So some contracts will simply not take your money. The goal of this level is to make the balance of the contract greater than 0. Things that might help. Fallback methods. Sometimes the best way to tag a contract with another contract. See the section. Okay. What the heck is this? Alright, I don't need that. So I'm pretty sure we just have to make this balance increase, and there's no call to like actually do that. I'm confused as to why it's saying fallback methods. There's no fallback methods here. So this is what we basically need to do is force send ether to this contract, right? And this is actually a good exercise. That's up, Byron. Oh man, let me respond to this. Let me show y'all something. Oh, that's a long link. I'm not putting that in there. But and also Byron, if you want to join in on the Discord, feel free. If you want to chat, you don't have to, but I have this open for people who want to chat with me. And if you want to study something, like say if you're about to say you're working on Scala stuff or whatever it is you want to study, you can just mute me and not have to worry about me messing up your study session. So All right, so let's jump back into this. So with ethers, so this is actually a great exercise because I was just doing an audit where, and this is on the Cosmos side, where there was some logic that didn't take into account being able to send money directly to a contract. And it wasn't not necessarily that it like resulted in a bug or high severity finding, but it led to some more checks and some more things I needed to understand about the contract. So with a lot of these, your contracts have state variables that take up and kind of record what's happening in terms of the contract, but they may need to take into account like the contract balance. So if you're able to force send money to the contract balance and there's logic that actually uses that balance, you may be able to manipulate or attack that smart contract. So this is a great exercise, and something I like doing if I'm ever jumping to a new chain is figure out like what is it like to send money directly to a contract? Is it allowed? Um, yeah, it's just a good mechanism to learn when understanding security and blockchain tech. So what I believe we need to do is two things. We need to set up another contract, right? And then we need to delete or destroy that contract and point the funds of the destroyed contract to this contract here. So there's no receive or fallback function here. So we can't just send money to this contract. We have to force send it here. And I think that's one of the only few ways is if we, let's see if I can get ChatGPT to help us. AI assistant. To do some explaining for us. I have to log in again. Let me pull this to the side. I'm not gonna do that on stream. All right. So you can kind of already see some of my other stuff, but all right. So, hey, audit assistant. All right. So let me force send ETH. That doesn't accept it. Let's see. Huh. For example, you could create a contract, accept Ether, and then have that contract call. I didn't know you could do this. I'm pretty sure it still shouldn't send Ether there, but I actually didn't know. The only way I thought you could do it was destroying a contract, but I guess chat didn't know that's an alternate way, so it's okay. Chat's still learning. So let's do one thing here. Let's make a contract. Let's call this attack. And what I'm gonna do is actually let's go ahead and we can have a constructor, even though I don't think we really need it. Actually, I don't need anything in here. I'm just gonna give this a receive function, right? I want this to be able to receive some money. Oh, no, 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 no. Here's what I can do. This is just much easier. So I'm going to have a function attack. And what we're going to do is make this payable. And then we're going to, I don't need anything here. Attack. And then I'm just going to call self-destruct. So self-destruct allows us to destroy a contract. So I still need a constructor because I need to create this other contract. So yeah. So first, let us get this force information. So we're going to import force.sol. Okay. And then we're going to create this contract. We're going to call it force contract. And let's change this to force. Okay. I got issues. Really matter? Abstract. Let's try that. No. I'm going to be using this in a second, so we will see what the issue is. Alright, so we're going to have address. What's this? Payable. Okay. Well, actually, I actually probably don't even need this. No. Pass in the force contract. Oh, nice. so we have this address here. And then what we want to do is call self-destruct. And we're going to send it to this address. Anytime I call this attack, and when I send this a message, I'm going to call something like attack and then pass in a message value of like 5, a balance of 5. Because all I'm doing here is just paying this, depositing money into this contract. Which should work, but we'll see. We'll see if not. If not, then we can just call the receive function. Send some money to the contract first to verify that the balance is greater, and then send it. But that's essentially, we can do this all in one step. Put like force contract, it's payable. Yep. I wonder what's going to happen whenever this does get deprecated. Will we be able to call self-destruct? Is there anything else we can do? Okay. So it looks like this should work. We're going to test out our exploit by coming to test. This is going to be a contract attack type style because we have a contract that needs to do some damage to the contract we're trying to break. We're not going to just be doing this from a MetaMask accounts perspective. This is all going to be from a contract attacks perspective. So let us close this out for a second. And let's get our attack set up. Oops. Let's get a new instance. Go ahead and pay for that. Alright, bet. So we got our instance address, which is essentially the address of this contract here. So let's go ahead and grab that contract address. We have force contract, we have the attacker, the contract address, and we have the balance, which is actually everything I need. So in my attack flow, I want to first send ether to my attack contract, and then self-destruct, sending the coins to the force contract. And a key piece of this is whenever you call self-destruct, right? This address here is the address where you want all the funds of the destroyed contract to go to. So say I have this attack contract, I send 0.01 ETH to it, and when I call self-destruct, the address that I pass in is going to be the address that's going to take this money. And honestly, I don't even think I have to do payable here. it's going to have to go there. But let's see. Does that change anything? Okay. So I guess we need a payable. All right, and then this is important because this is our test case. So in our contract attack force, in this, we want to make sure that the balance to be greater than or equal to 0. Actually not equal to, but to be greater than 0. So we want to insert contract address of the Ethernaut challenge. So we got the force contract, get contract at force at the following contract address, which we've already completed. We're going to get the balance of this contract. It should be 0 here. And we're going to print this to the console to make sure it is exactly 0. And then I messed up here. So attack flow is view the original balance of the force contract. Should be 0. Then we want to call our attack contract, and that is called attack. And there's no parameters or arguments we need to send with this. Now what we do need to do is, I can't remember how the value is sent. I think it's like this. Value is going to be, let's look that up before I make a mistake. Okay. Here we go. All right, so this is right. This is the right format. So we want to send, I'm not sending that much ethers. I'm just going to send 0.001. As a matter of fact, I'm going to send even less because I love my testnet money. And then, yep. We're going to wait for this transaction to occur. And we're going to print these out to the console. And then afterwards, we want to get the balance. So um, force contract dot balance of contract address. Um, we want to the balance of the force contract address is equal to balance and I don't need the balance of my attacker contract. That's not necessary. All right, this should be how the test flow should work. This is like the high level overview. Really quick, why did I not use attacker? Okay, yeah, I don't need this attacker. I'll leave it there though for my next template stuff. All right, so yeah, so this is the flow of how this exploit is supposed to work. Now let's try and actually do the exploit. And I want to see what this means. I have no clue what this issue is talking about. Oh, okay. All right, so I'm seeing now. I really didn't have to. I really did not have to use an initializer, like use the constructor to bring in this contract info. I honestly could have just, I could have just passed in this like address that we want to send it to, and one function here. But this is fine. This accomplishes everything. Is that my boy? That's Deuce. What's going on?
Yo, what's up?
Nothing much. How you doing?
I'm all right. Yeah, I was just checking in, see that challenge.
Yeah, yeah. Cool. Yeah, we're streaming. Just forewarning, so don't say nothing. You don't want to be on YouTube. But
Yeah,
what'd you say?
don't know if you saw the comment, but there's actually a EIP out now for removing self-destructs.
Yes. So what I'm thinking now, like this is a good problem because so when I was doing when I was doing the research, it was saying that oh no, and here it's cool that Solidity developer tells us that it like what's about to be deprecated, and so
Oh yeah, yeah,
I was thinking like, what's gonna be the way to force send ETH to a contract after this? And I'm guessing maybe not. If you don't have a receiver fallback, I guess you just can't. Which is good from a
yeah.
security standpoint, right?
I think
Oh shoot! Hey Robert, you cut out. Can you hear me? Uh oh.
yeah.
My Wi-Fi might be bad.
Oh, I was just saying. I think that was one of the reasons why they're removing it.
Got you. Let's see. Can we send ether? Can we force send ethers after self?
Person who's coming to talk at the next Solidity ATL was they actually had an opportunity to hop on a call with the Ethereum Foundation about this EIP.
Really?
and they want like a path to keep self destruct if they like a compiler option or something to keep it.
Mm-hmm.
Um, so it's interesting about like all the use cases that self destruct can impact.
Yeah, that's interesting. Yeah, that's really interesting. I was talking earlier on Cosmos. I ran into on the project I'm on. I ran into an interesting use case where, like the Cosmos blockchain, there's two ways to receive for your contract to receive ethers. So it's like similar to not ethers, sorry, but to receive like Atom and Cosmos based tokens. You can implement this receive type of entry point, and then you can also use the native Cosmos chain messages to send ether or to send Cosmos directly to a contract. And so I had
No.
found this issue where you can kind of like pause this contract because they didn't. Well, I thought they didn't take into account the contract balance, but it came out later that that wasn't the issue. But it was just cool because I learned so much about how Cosmos accepts like native tokens. So it's interesting because it's like it's a place where a lot of vulnerabilities can come up if you can force send money to any type of contract, no matter what blockchain it's on. It's like good to learn this fundamental thing.
Yeah, yeah. That also means that every chain could potentially do it differently.
Mm-hmm.
So like even if your code's safe on Ethereum, it may not be on Binance Smart Chain or
Yeah.
Polygon.
Yeah. So yeah, real cool stuff.
Oh,
I don't know if my attack contract is gonna run, but I'm gonna go ahead and test it out. You came right on time. So let's compile first. Anything also before we go off? Anything you studying right now or want to study?
I'll probably study in a few hours. I have more errands to run.
Okay,
I've been helping someone move for the past few hours, just taking a break.
gotcha. Cool, cool. All right, so our contract's compiled successfully. Now let's go ahead and not run, but test. Let's go ahead and test this and see where we get. We will likely have some issues, but that's okay. No, no, no. It's not template. It should be force. All right. Let me make sure I print out the transaction logs because okay. Let's give this a shot. Force contract dot balance of is not a function. All right, so force contract. Where's force contract? Ah, okay. I may have made a mistake with how I deployed this. Okay, I passed this in. I should have deployed this. No, that should be good. Let's see. Hmm. That has an address. let's try to see. Let's make sure stuff deployed because I think I messed up somewhere. It's looking like there may not even be a contract. All right, let's try this again. Okay, so we have the contract here. Yep. Now why? Oh, okay. I see why. Because I think beforehand, I think I just used the wrong function. So let original balance equals await ethers dot balance of. Okay, I think that's it. I was using the wrong function. So let us grab ethers dot balance of, and I hope this transaction didn't run. Let's go to the wallet. Okay, I think we're good. Oh dang, it is doing it. It's creating the contract. But it shouldn't be doing anything. Alright, so let's retry this again. Does ethers not have a balance of? Ethers dot. Maybe it's just balance. Okay, let's try to figure out what's the right way to get ethers. Ethers balance. I would never do that to my computer. So I think we should do get balance. Yep, ethers. Ethers dot get balance. I wish I don't see it. Maybe it's ethers dot provider dot. All right, let's try this. Okay, one more time. And I'm losing testnet either because I keep deploying this contract every single time, but that's okay. It's deploying. Alright, the original balance is 0. Let's run our attack. Alright, well, we got a exploit. You saw an exploit live. So let me just walk through what's happening. So here, all I'm doing is grabbing the details of the force contract. That's what this little bit is doing. And then afterwards, we get this console log. Remember, I want to see the original balance of the attack contract we're trying to attack. And then we have a I need to figure out how to actually look at this receipt. But basically, we have an object which is the transfer transaction, which it's not showing, so I don't know why it's doing that. But this is basically supposed to show details about this transaction. And then the new balance is this right here. So that's approximately this amount of ethers right here that we showed. So this test passed. It's basically saying our balance is actually greater than 0, and that's how we know we committed the right exploit. So I think something I want to polish up is showing these receipts, and I don't know why. I don't know how to view a receipt. Let's look at it. Oh, I wonder if the reason why I'm getting that message is because the transaction's already been done and I need to get the receipt separately. Hold on. Try this again, just for the fun of it. The balance is going to be incremented again. No, it's still not working. Why is it just giving me the object? Laptop's gonna die in a second, but view transaction details Hardhat. Yeah, it's still not working for me. Hmm. I don't see why this is not working. This used to work for me. Transaction. View details of a transaction. Hardhat. Let's see. Nope, not in Go. Maybe how to view transaction object. Hardhat. Okay, maybe chat knows. Okay, maybe I can look up a quick YouTube video. Transactions, Hardhat. I kind of can't wait to switch to Foundry because let's see.
What's up, guys? Let's do console log to compile. And this is what I mean. You see how it worked like that? And it looks like it sender bounce is percentage time, 100% grasp on everything that's going on. You just kind of have to be able to walk message sender. Yeah, so I guess, right,
No, this only does it from the contract perspective. I don't want to log message from the contract. I want to log messages from JavaScript, my JavaScript test. So won't even show me details about this object. So the transfer transaction is object. Console. There we go. This thing looks thorough. Debugging. Okay, so I'm not finding that right now. If anyone's watching this stream later and you know how to do it, then send me the reason why I can't print out the object. I'm pretty sure using .toString is not really going to help me, but let's try this. One more time. Let me get my charger while this is running. I'll be back. No, I just need my charger. Coding crazy. Coding crazy. Alright. And it did not show. Okay. I'm not gonna mess with that no more. It's kind of messing up my flow. Yeah, I really don't know why this is not showing the actual receipt. And we have an object. How can I view that though? Yeah, I really don't know how to do this. Or not how to do it. I think I've completed the challenge, but um, definitely not defined. Okay, let's try this again. I'm pretty sure it's gonna give me the same message, but we're gonna go ahead and submit this challenge. Oh wow. Ah, false alarm. But it's still okay. No, it did show it this time. So that is very interesting that a string literal allows me to not print out these transactions, but whenever I just do it this way, I can. Okay, so I guess we solved that issue. Let's go ahead and submit this challenge. Learn something new. Where's Ethernaut? Just back out of all this. Alright. So let's submit, and we should get a acceptance message. Let's see. Let's go. Alright, so we completed this challenge. We know how to force send Ether to a contract for now. May change because of the self-destruct opcode being deprecated. We also learned how to, we learned how to self-destruct, so how do you actually destroy a contract and point it to something else. And then we also learned that if you use string literals, you will not be able to see the object. So what did we learn today? We learned self-destruct allows attackers to force send ETH to a contract. We also learned that don't use literals when trying to evaluate or console log transaction and transaction receipt. And then also we learned that self-destruct opcode will be deprecated soon. Okay. Seven and maybe 8. Let's see, how long have I been streaming? So that took an hour. Pretty cool. That challenge took an hour. So I still have about another hour to kill or to spare. I say to kill. So let's go ahead and try the next one. Let me do some housekeeping stuff first. First, we have to add this to GitHub. Complete force challenge in contract attack force.js. Git push set upstream to force. Alright, that's on GitHub now, so anybody who's watching this in the future, and actually let me, I need to start doing this, honestly. No, Ethernaut. Alright. just throw this in the chat. Solutions for each level. I should have been sharing that, but let's go ahead and go on to the next level. So let's exit this. Let's go to terminal. Drop this down. The next level is called Vault. Okay. Git branch. Let's call this vault. Let's check it out. And we're going to do our typical setup for an exploit. So let's I kind of don't know if this is going to be through a transaction, but from the looks of it, we only need a externally owned account to work with this. So let's use this setup here. I'm going to get rid of this force contract. Let's change that out. And for attack, let's go ahead and just comment all of this out. Okay. We're going to clean up our Hardhat because it still has the info from the last challenge. All right, now let's figure out how we can exploit this contract. So let's look at the, oh sorry, one more thing. Let's get a new instance. Okay. Got us our instance address. Let's go ahead and throw that join right here. Right here. All right. So unlock the vault to pass the level. So that's all we get as a hint to how to complete this level. Assuming some. Let me capture this before we do our code analysis. Let's change this to volt. And let's compile this to see what's up. All right. So this has already been copied. So we're on Progma Solidity 8.0. Those out of the way. And then we have a Boolean value that represents if the vault is locked or not. We have these bytes 32 to show the password of the vault, which is private. So interesting thing here is that Private data is not technically private. Because it's on chain, you can see this data. Only difference is there's no callable function for private data. So like for instance, I can't just call like contract, like vault contract dot password and expect that to return the password value, right? I can't do that. I can, however, call locked, or sorry, I can call vault contract dot locked, and it's going to tell me if it's true or false. It'll give me that data. That's the only difference really. But there's ways to see at the bytecode level, I believe, like what is this value. So here's what I need to do first. I need to, so there's a constructor that tells what this password is. So what I need to do is somehow access this password data to somehow access the private data. And once I get this password data, I can call unlock with the password and complete the level. But let's ask our auditor friend, our auditor's assistant, how can I use ethers.js to view private data in a contract, in a Solidity contract? Okay, that's not what I want. I'm sorry, not doing good today, but it's all good. Okay, that's a good one. Get storage at. Oh, the storage slot is byte 32, so that should be the answer as it comes. All right. What data types? Okay, so I think what I'm about to do is get storage at. So get the storage slot of 1. And then once I get that storage slot data, it should be as a bytes 32. And then I can pass in that bytes 32 to the password function to unlock the contract. Here we go. Let's read about Ether's get storage at. I think that'd be a great way to understand what's going on. Yeah, this looks like a good write-up. Of course, I'm not about to read this whole thing right now, but let's throw that in our notes and say getting storage slot data. All right. So that looks like a pretty good write-up that I can read later on. Oh yeah, what is the Ether's equivalent? Okay, so I just gotta do provider. Nice. All right, so it returns the bytes 32 value. Can I convert the bytes 32 value if I want to see the actual password? Oh, let's see if they have that ASCII thing we just saw. Nope. To ASCII. Parse bytes 32 to string. All right, so I think I think we're good. I think I have all the ammo I need to see what's going on. So let's set up this attack. What's this? I need the API coder. I do need provider. All right, so we have a vault contract. An attacker, contract address. We don't need the new owner, but we do need the unlocked. It's going to be a boolean. So we have an attacker. We have, I think I already got this, but what's the instance? We have the instance address. Now we need to get the contract at Vault at this contract address right here, which is going to basically bring in what's been deployed already. We don't need any of that. Okay. So to perform this exploit, let's grab the bytes 32 value at slot 1. Or yes, I think that's going to be slot 1. But you know what? Let's just see what slot 0 gives us. It's just tell us whether it's Boolean or not. So let's get the value at slot 0. We should see a value of locked, which I believe would be a value of 1, which I think represents true. I don't know. We'll see. Second thing we want to do is grab the bytes 32 value at slot 1. We should see a of okay, and then last step in the chain is to call unlock. We want to call the vault contract dot unlock function, and we want to pass in the slot 1 bytes 32 data. Okay, and that should unlock the vault, resulting in a successful exploit. All right, so how we're going to set this up, y'all? We're going to first expect unlocked to be true. Can I do that? I don't even know if that's a thing. Let's check this out. try assertions. Oh yeah, I can. Expect to be true. Okay. So, fourth step is to confirm that unlocked. No, it should be false. Okay. Okay, so let's try to work through this, the logic of this attack, and we'll go from there. Kind of just work through how an attacker would approach this. So let's grab the bytes value at slot 0. So let slot 0, let vault contract slot 0 be equal to I don't even think I need providers. Get storage at. Okay. And we're going to get contract address. And let's try at slot 0. That's going to be vault contract slot 0. Okay, so we're going to grab that second one, that first value, sorry. And then let's, another thing I want to do is, no, that's here. So console.log, the vault contract value at slot 1 is, and we're going to say, do the same thing here, but we just need to say at slot 1 and change the storage address, the storage slot position to 1. Okay. And we're going to say vault contract slot 1. Now this should be bytes 32. Ooh. Let's see what this returns. Okay, it returns a string for sure. How do you convert to bytes 32? Convert, let's check chat. Oh, my bad. Wrong thing. Okay. So Ether's a YouTube's format byte 32 string. So I think I might have to do that, but let's just try and see what happens on its own. This is why I really need to learn. Yo. This is why I really need to learn type chain and get more and really dig into TypeScript. Okay, so we got, we grabbed the bytes, and I believe it's going to be bytes 32. Grab this value at slot 1, and what I want to also do is bonus, let's view the bytes 32 as a string. So we're going to say password slot 1 as string. Let slot 1 by 32 as string equals, should we await? I don't even know if this is a promise. And let's do bam. Bam, bam. Console.log leave slot 1 bytes 32 value. As a string is all right, and now we want to call the unlock on the contract. So let's look at how this thing is structured. Unlock the swag, unlock. Okay, inputs byte 32. All right, bet. So we know that all we have to do is let transaction unlock equals await, and we're gonna have vault contract dot unlock. Oh no, not unlocked. Dot unlock, and the input is going to be contract slot 1. That's my guess. We just pass in that value. Now it is. Yeah, parse bytes. Yeah, okay. That should be the string. Okay. Is there a way? Yeah, I think I can just pass that value. I should be able to pass that value, but I think where I might run into an issue is I may have to do something where I like strictly convert this into a like bytes 32. No. See, I want to format it like pass in the type as byte 32, but I don't know if that's. I think JavaScript may make that difficult. This is where type chain will really be important because I could just say this is going to be a bytes 32 and pass this in. But we'll go from here and just see what happens. So, console.log. Remember, we have to await, make sure the transaction actually gets processed. And then after this, grab. Sorry, I'm going to use step 5. So what we want to do here is grab the unlocked value. And I only have to put I don't have to instantiate this because I already instantiated it up here. So I just gotta say unlocked is equal to await vault contract dot unlocked. Oh wait, no. It's just locked. Yeah, it's this value. So check if that's locked. Yo, what? All right. So we're setting up our attack. I think we're just about done. Let's rerun through this. So, and I don't need attacker, but it's all good. So we have our vault contract, we have our contract address, and if the vault is locked, honestly, I don't need attacker here, but I'm gonna keep that because that's usually in my template. So we have the contract address of the instance. We're going to get the vault at this contract address, which is going to be where it's deployed. We want to get the first value at the slot to see if it's locked or not. It should give us a value of 1 to represent that it's true. And then we're going to get the second value at the storage slot 1, which should return like a long value of bytes. So it's going to look like, I think we have some, it's going to look like this. So it should look something like that. We're going to print that out, see what it looks like, and then we're going to convert that to a string just to see what the actual password is. And then here we're going to call the unlock function. So that's this. Call the unlock function and pass in that password, which is a bytes 32. So we call in unlock, we pass in the value at slot 1, and then we're going to get the receipt, or wait for that transaction to actually complete. We want to look at this receipt for the transaction, and then we're going to check and see if it's locked. And at the end of the day, we want to make sure that this, ooh, good catch. That's why you should always go through pseudocode and reread your code to make sure logic makes sense. At the end of the day, we want to make sure that is locked value is false. And it may return as a string. I don't know. What is this going to return to us? Okay. Alright, so let's set up this attack and run it. We want to make sure it all compiles, which we checked already. And we want to test this. See, this is why I said network. Okay, so we got to, so all right, we see that this is 1. We got this long value here. invalid bytes 32 string. Where is that at? So we got to this. We didn't get the slot 1 value. Okay, so it looks like it threw an error here. I don't know why this is not working, because we grab this exact value that's printed out here. Let's see what we got. Nice chat, GPT. Looking out. Good looks. So we want to so it looks like it's already as a string, right? So first we have to do something before it. So let slot 1 2 bytes equals and we're going to pass in the contract one. Let's try to join. Still even after we convert it, we still get that issue. Okay, let's try that. Okay, how do we add a null terminator? Ooh, I need this. I definitely need that article. Let's read this later. Yeah, I'm not really getting how this is not converting it because this looks like a bytes value, but let's go ahead and say attempt. Okay, so I don't know how to view this as a string, but I'm going to skip that for now. I'm going to call this with this value right here and see if it unlocks. Nice. Nice, nice, nice. Okay, so we know it's locked because it's true. This is the transaction we sent. This is the receipt. And the vault is now false. Okay, so that worked. We successfully exploited this and have unlocked the contract. I think the only outstanding thing that I want to learn is how do we view what this actual password is. I think that will be something that's interesting is like, okay, we can get the data, but how do we view it? And obviously, like as a security person, you just need to know how to complete this challenge and how to get private data off chain. But I really want to know how to decode this data and see what it's saying. It'd be cool to see what that actual password is. So let's see, convert bytes 32. So yeah, if you see this and you know how to get the actual like string representation. Okay, so storage value gets a big number. Hmm. Okay, so let's try this. Um, so we get the storage location, right? Or we get the storage slot. Get storage at. All right. We already know it should be padded already, but yeah, let's try this. I'm just gonna copy this. So let's say padded slot is equal to ethers dot utils, and we're gonna say 0k storage location and padded slot. Yep. No. Slot 1. So we got the padded slot. We get this. String data utils. No, wait a minute. I think I want to see it as a string. I think that just got it as a. Yeah. I don't need this because this is just gonna get it as a. Actually, wait a minute. It may be a tad bit different. So let's look. I also want to console log this out because So all I'm doing is grabbing data. I'm not trying to run this exploit anymore. We know it works. This must be some deprecated. Hmm. Hmm. Okay. Well, this was the password, and this is how you actually see what that data is. I'm guessing the reason why we couldn't get it. Actually, let's try and do it how we had it. What if I take this out? What does this do? It does. Okay. So we didn't have to do all of that stuff. It looks like all we had to do was this. At least let's see for now, because this may have padded the slot. So let's take this out. Okay, and let's do string data is going to be I guess we just turn it to a big number. Okay, and let's try that. Yes, the storage slot data is a very strong secret password, so that's what that was supposed to be. So we just learned a few things. We didn't need this. And let's go ahead and uncomment this out. Okay, so that whenever someone goes to actually do this, they can okay. Yeah, so we figured out a few things that was in addition to the exploit. So not only did we learn how to view private data, but we also learned how to take that data as a representation of bytes 32 and convert that into a string. So beforehand, I just learned how to do this, but now I know how to take this byte 32 data and convert that to see what's actually happening there. So we saw that we were able to successfully complete this challenge, but the final test is to what's going on, Robinson? You can hop in the Discord if you want to chat and ask any questions. But the final test is this. Let me actually throw this in the chat, so that anyone rewatching this video will have a good understanding of how this problem was solved. I'm going to do this myself. I actually did not read the whole thing. I kind of just took what I needed from it. Yeah, I took what I needed from it to get the answer. To pretty much do the exploit, which it's like the hacker's way. It's like pick and pull what you need, and then later on, like later on, if you need to learn something, then you dive deeper into it. But for now, we complete this challenge, and so I'm gonna check and make sure that was right. So let's submit this instance and see what we get. And that would be the first time I did 2 challenges in like the span of time. Alright, let's see. Let's go. Alright, so we just did 2 whole challenges. What's this next level? King. We are knocking through these. I want to get to... Thank you. I'm sure once we start getting into like Gatekeeper 1 and 2, I think this is where I'm gonna have to look up answers as we're doing the stream. But we'll keep rolling with these. I'm thinking about doing a quick workout, and I might pause from this for a while, but let's see. It's 4:30. Yeah, I'm probably gonna pause for this for a while because I've been going pretty hard at it for the past 2 hours. Let's see how long I've been streaming. About 2.5 hours. So what I'm gonna do is probably pause. I might stream later or I might stream tomorrow, but yeah, if you want to go back and watch the past 2 hours, I pretty much went through Force and Vault. You can kind of just see my thought process on how I went through it. Thanks, Robinson. See you soon. Alright. So, yeah, I'm going to go ahead and end stream now. Thanks, y'all. Feel free to DM me if you have any questions. I'm about to head off.